right, what up, Steve? Welcome back to the show, man. KDABET's team in the house. How you doing?
I feel like I just saw you.
Long time no see. So today we wanted to dive into all things Kadena. Me and Steve were talking a second ago, and it's such an honor to have somebody that believes in the Kadena technology, that is way more talented and knowledgeable about the tech than I am, that believes in it just as much as I do. Hopefully you can just shed some light on what brought you guys to Kadena, why you chose Kadena. We had talked a little bit in other videos about how you've tried to build this application on many other blockchains, but it just wasn't possible. You needed a technology with a public and private hybrid blockchain. You needed a safe and secure smart contract coding language like Pact. You needed the resources and team, and everything that you guys were able to build wasn't possible in any other blockchain. So why don't you guys take us from the beginning? Tell us like when you first tried to do it on Ethereum, what limitations were there on Ethereum, and then when did you find Kadena? We'll kind of go in order, but let's start with the Ethereum part first.
Sure. So I'm sure Duncan will fill you in more on Fans Unite and what we tried to do in Ethereum. So I'll try to do it justice, but keep it short and focus more on Kadena. And so I'll talk about ETH and the problems that we found. So I was part of a company called Fans Unite Incorporated, Fans Unite Entertainment. Started in 2016, and that company was pretty much one of the first guys to raise money. We raised about $10 million to build an Ethereum-based smart contract for sports betting and exchanges. So it was just a protocol, and that protocol, its utility was the oracles, basically. So we were trying to decentralize the oracles and incentivize people to provide data to the blockchain that was secure, right? So kind of an oracle-based play. In hindsight, it wasn't very great in terms of its utility, but it was 2016. We were just trying things out. Like, can we even build sports betting on Solidity, right, on ETH? And it turned out no, for many, many reasons. But the big ones were the fees, of course. And, in sports betting, most people bet $100 aside. And so giving up $40 to $80 of your transaction, depending on the rate of mining, I guess, if it gets really, really hairy, you're just paying crazy amounts of money, even more so than the bet alone. So you get on MetaMask and it's like you're not, it's impossible to make money. So you would just be betting into a black hole abyss. And that was Ethereum, is the fees. The gas is terrible. And I think like guys like Vitalik even know that, right? If you're not rich, it's just hard to partake in the Ethereum network. But even more so, it was more so the programming language. So any blockchain, Ryan, that starts the genesis, at the genesis of the blockchain, picking smart programmatic solutions to what you're building is going to is basically going to give you the success. I call it the success REPL. You got the concepts, REPL. So it's the concepts, and then you filter the concepts, and then you relentlessly execute on the concepts, and then you loop back to the top and keep this cycle going. But that very first generation of decisions you make will kill you or not kill you. So I want to explain something to you that doesn't get a lot of attention on Kadena, and it's the difference between a declarative programming language and an imperative programming language. And Solidity is an imperative programming language. So I'll explain this concept to you. Imperative is when you tell a computer what to do. This is how you put everything together. So this is how you put a smart contract transaction together with a lot of logic like ifs and elses. In a declarative language, you say exactly what the thing is. So this is what a transaction is, and then you bring that to data which already exists and is immutable. So Kadena is a declarative smart contract language. I'll tell you why this is important. When you do something in an imperative language, the problem is that you can have many, many mistakes because the language is closer to the CPU, okay? So like you're saving data in the CPU and your logic, you bring your data to the logic, you do a computation, and then you have all these things like ifs and elses and loops and for loops and all these types of things that happen to make sure that your program executes. And what that does is it leads to all types of attacks that can be made. So if you're not very, very careful in an imperative language, and you can introduce things like, something called nulls, so you can say like, I want to send this amount of money to this wallet, and then the result comes null. And then the program doesn't know what to do. It's like, thank you, your amount of tokens sent to me is null, so I'll send you nothing. And all these bugs can happen in Solidity because it takes a lot of care and effort to tell a computer what to do. But in Kadena, you just say what is. So I'll give you an example. On the Marmlade smart contract, they very carefully say this is what a Marmlade transfer is. It's an offer, it's a buy, it's a withdraw, and then a cross-chain transaction. They define the whole operation. and then they bring your data. They have your data, and then you bring that transaction to it, and then woof, it gets done just like that. And that type of programming language, a declarative language, reduces the attack vector. So they call it the attack surface. The ways you can attack and hack that program drastically shrinks with Kadena because it's a declarative language. That is, under the hood, there's a programming language called Haskell. Haskell is deeply known in the community of functional programmers. So that's another word for declarative programming. Functional programming is a type of declarative programming. And Haskell is very much on the safety side of the spectrum, where Solidity JavaScript is way back here and just rife with errors because it just tracks coders who want the simple life and they don't know how to control their logic very much. And these types of things called like loops and crazy loops, it's not allowed in Kadena. And it's very, very to the credit of Will Martino and Stuart Popejoy, who invented this. They have this thing called Turing incompleteness. Now that's just a fancy way of saying no loops, no crazy loops, no endless computations that can go to infinity. And that's why gas is so much, because you have infinity computation. And on Ethereum, that's what you're paying gas for, is this unlimited compute. So they wisely made these decisions of not allowing these imperative language structures to exist. And they made Kadena only for transactions. So just transactionality is what they're going for, rather than this general computing environment. And that's what we saw right away and attracted us to Kadena. They're like, oh, okay, they're building this for transactions, not for some general computing environment like Ethereum. And sorry, that's a very long explanation, but that's the very first thing we noticed. And it was like, boom, we know this is a serious project.
And can you explain how and where did they add formal verification? I know that I believe comes from Z3 or Z3, but how does Pact take Haskell, they take Z3, they take Lisp, they take all this and they combined it into one? Can you explain a little bit first about formal verification and then how they implemented all that together?
Yeah, I got to say that that's probably the part of Pact that we're still trying to wrap our heads around. And I'm going to be honest with you, because my CTO Martin would get very mad if I talked about something I didn't totally know about. I do know Z3 is a very, very, very strong. I think it's like bug checking software. That's how I understand it. It helps the compiler check for bugs, and it's very, very well known and built by Microsoft. So I'm going to say I don't know yet. I know what a formal verification is, but I don't know how it interacts with Lisp and Haskell yet. So I'm sure that's very complex how they did it and how they plugged it in. But generally, when I start up Pact, I just install Z3 and it works. So I know that it's doing its thing, and its compiler is being supported by that. That is Pact's compiler is being supported by that. That's when you compile all your code to deploy it into the smart contract node, I suppose. So I'm going to just not try to answer that, Ryan, because I just don't know how that all fits together. But that's something that's on my plate.
Perfect, man. Perfect. Yeah, I fully understand formal verification and how that it's basically self-auditing itself. I was just curious, that is a completely separate program, right? Like Z3 is separate, that that interacts with Pact, right? But when when you're writing code and Pact is giving you the error, it gives you a little red box like instantly and says, hey, you got something wrong. Is that Z3 or is that built into Pact?
Yeah, it can be built into Pact. I mean, you don't even need Z3. You can do this all in Haskell. So in Haskell, when you write functions in Haskell in a declarative language, all of your outputs have to be known. So if you take an input, you bring a function to it, you have to write down all of the events that can happen. So you can't have a function that returns a null or a nothing. It's like I have no value. No, and you have to, like I said, in declarative language, you have to say what is. And you can do this entirely in Haskell. It has a beautiful compiler. But I think what happens, so there's two distinctions here. In Haskell, you have things called pure functions, and then you have impure functions. And pure functions basically are flawless. Like if you take a well, not flawless, but pretty close to. So if you publish a module with just pure functions, which is like, take a number, add one to it, you have an output, which is just an integer. It always knows what that's going to be. That's a pure function. But sometimes when you're dealing with things like it's called state in computation, and you're dealing with the outside world, like sending information across a server. So you have a function, you get a result back, you send it across a server. Now it's impure function. And I think what Z3 does is it just supports things that Haskell has troubles with. But in the end of the day, even Haskell can have, which is what is under the hood here. I mean, the Lisp is just a language that's on top of it. That it's easier to code in that than Haskell. So you type your pact in Lisp, but what's really going on under the hood is Haskell. And so like, I guess Z3 just interacts with it because it might just have a lot of libraries that deal with things like server communications. So like, I want to talk to a Flux node or something. And when you do that, you're exiting your pure functional space, which is known. And when you compile that, like no bugs, and Haskell is beautiful error checking and everything. But now you're entering into a world where you don't know what's going on, right? Because it's another server somewhere else, may not even be yours. So I think Z3 just has a lot of, I'm just guessing here because I don't know. I just want to be clear, I don't know. But I'm guessing it just has a lot of nice libraries that Microsoft wrote over many, many years. Microsoft, of course, 500 billion or something, like stupid amounts of money. So they have so many people who could write all of this nice error checking code and testing code. We call it unit testing in code. So you're testing like, does my transaction work? Yes, therefore I'm ready to deploy. I think Z3 just has a lot of that stuff done. Instead of writing it all in Haskell and, just killing the Kadena Pact team with 100 years of work, you just piggyback off Microsoft and use some of their impure function checking code. So I guess that's what Z3 is in my mind.
It's so freaking cool, man. I love actually hearing all about this tech, man. I love the honesty too, man. I love that you're just straightforward about it, man. It speaks a lot about your character, man. And you're
still learning, right? It's still learning process always.
Very new, and they just announced yesterday, I don't know if you caught that latest Medium article, they are working on building out Pact University courses that are going to give you like an efficiency badge or a completion badge. So once you complete tutorials A, B, and C, you're going to get a certification, and you get a next level certification. So it'll be easier for people like yourself to find devs. And it's like they made it very clear that they've heard a lot of the complaints. They wrote in the article about what the complaints were and everything like that. So it really seems like the Kadena team's going full send right now, like really doing the things that they need to be to attract those bigger players and to, attracting players like yourself. You have your master's degree. For anybody that doesn't know, that didn't watch our other interviews, they should. And then also heard you give a big shout out to Flux in our other one. So I'll let you take the honors of giving Dan the shout out in this one. So go ahead.
Yeah, Dan Keller, such a great guy. This guy is true blood Web3, anti-whale, I shouldn't say anti-VC, that's a terrible thing. I shouldn't speak for Dan, but let's just say that he encapsulates the ideals of Web3 and what it's meant to be. And he's a true champion. And I think that's why he blends well with Kadena. So we're going to be working with Flux to just, I'll tell you a little bit about our engineering strategy, right? So we're working with them. We got accepted into the Flux Labs Plus program. And we met Dan and Lucas and all those, and Emily and all those great people. And we're going to be working with them to get off centralized, as much as we can, to get off centralized infrastructure and use Flux. The reason why is Flux, like always in crypto, puts a two-way market on the price of computation. EC2, it's a monopoly. You have to pay them whatever the heck they want. And so right away, that reduces our cost structure from a strategic point of view. You don't mind if I dive into our code structure?
Love to,
how we're going to use it? Okay, I'm going to go nuts, okay?
Dive deep, homie.
Right on, man. So what we're going to do, like how a sports betting exchange works in Web3 is going to be like this. So we build our interface in a programming language called Elixir. That's a declarative language, just like Haskell, but it's meant for high concurrency. It's actually built by Ericsson, and Ericsson is a telecom company. So it's meant for like telephone companies, which in about 60% of all communications in the entire world. So 60% of all bytes in the entire world, ones and zeros, go through Erlang. And It's meant for this bulletproof, like it can never die. It's amazing technology. I'm an expert in Elixir and Erlang, and so is our tech guy, Martin, who's actually a little bit way better than me, actually. I'll say way better. And what we're going to do is build that front end in Erlang and Elixir built for massive concurrency, okay? What concurrency means is that people are going to come in, and how people work with bots in the sports betting space, Ryan, is they come in and they'll slam 1,000 transactions like that. And so you can imagine we have a front end and the guy is like, okay, give me 1,000 transactions programmatically on a bot across 50 markets now. So all those 1,000 transactions come in, and we can't lose a single one of them or our reputation will suffer. So we have to build in this bulletproof language called Elixir that, if any one of those processes handling that bet dies, comes back to life like a phoenix. And takes the state of the bet and then just keeps going on. So it's called a heavily redundant programming language. That's our front end, and what's called the middleware. That is, you're handling the bets and then distributing them to Flux nodes. And then what we have to do is we have to send that betting data to what's called a matching engine. And this is what we're building right now. So we started our build last week on Pact and Kuro. So we use Kuro first. Why? Kuro is super cool. Nobody talks about Kuro with Kadena, and that bugs me because that's like its coolest feature by far, in my opinion. Because you have the chain web, which is the public blockchain where all the miners live, and then you have Kuro, which is the private blockchain where you can do private data or private transactions at a high TPS rate, and then send that data on chain, maybe an aggregate or something, you know? So imagine all these little bettors, and say Ryan Matta, you're a $100,000 bettor, or you have $100,000 of positions, and a bunch of me's come on with little $100 positions. We all go into a Kuro instance and we match up. So if you want the odds and I want the odds, we match up, and that's happening all the time at scale. That's what it's going to be like for our build. So in Kuro, because it's private, you can bet your $100,000 and it's not on chain, and that's important. And it's important because then I can't see what you're betting and front run you. That's so important in sports betting. Because if I see you betting, Ryan, you're a great bettor, I'm going to just copy your bets, right? Because I could see it all in real time. So if it's all on chain and I can see you, you're not ever going to get your money down because I'm going to screw you out of your bet because I know you're a great bettor, you're smart. So we got to put this on Kuro where it's private. And how this works with Flux, you know, so we're talking with Dan and we're learning a lot about Flux, and man, these guys are smart. You know, Dan Keller and his team are just amazing. And, you know, we're going to spin up these nodes that everyone's running right now, and we're going to put Kuro instances on it. So Kuro can handle 8K TPS right now. And we might be dealing with upwards of, you know, 50, 60, 70K TPS just before games start, NFL games, or the Super Bowl starts, or more importantly, World Cup. Holy crap, World Cup. Or if the two presidents, I don't want to say their names, I don't want to get in trouble, but you know the two presidents who are going to fight it out in 2024. You're talking 50,000 TPS just from that alone. So imagine all these transactions, and we got to split these Kuro nodes up on Flux. And so Flux people are making money, miners are making money, and we're pushing transactions to them, and the kings are making money, and it's all happening on these private Kuro nodes. So what happens is, like, you know, the market starts 24 hours before the game, and everyone's trading and matching up. When your position is totally filled and you're happy, you know, nobody's going to front run you, we push that on chain. That's when we push that to the public smart contract. Sorry for my hand there, but you know, you get the idea. So when you're done with your bet, we're pushing that on chain. And when the market starts and the game starts, that's it. The betting's over, right? Because we're not doing in-play betting yet. So just pre-game to start. We push all of that data on chain now. Now it all lives publicly viewable, verifiable on the blockchain. And then when the game's done, the Oracle data comes in to the public smart contract, wraps it all up because it's all in aggregate. The money passes to the wallets, and that's our build. So it's high concurrency elixir to Kuro, where everything's private and you don't get front run. And then it goes to on-chain where the miners can do their thing. Everyone gets paid. And it's all done on Flux nodes as well. So we're going to try to go 100% Flux and get those Flux people flush with transactions. And everyone gets paid in our network, which is exactly what we're going for.
Dang, dude, that's so freaking sick. Flux being wrote in Solidity. Is Solidity going to be a limiting factor for Flux, or is there ever a possibility of maybe somebody like Flux going, hey, we're going to do like a V1, V2 upgrade? We're currently in Solidity on Solidity World. We're going to do a V2 version on Kadena. Same tokens, same everything. We're just going to swap your tokens from ERC20 to KDA tokens, or is it just beneficial for Flux to stay in Solidity?
Yeah, I think they have to choose Solidity. I'm going to tell you, I'm going to try my best. So, you know, if my CTO puts me in the dungeon later, you'll see a dungeon graphic on our Twitter. You know, I've screwed up, but I'm going to try my best to answer this. It's bad. So look, they have to choose the EVM because a server is a looping process. It's an imperative process, not a declarative process. So Flux does not allow loops. And what is a server? generally. A server is a message comes in, something happens, the state changes, and you get a response back, and then it's always looping. So a server is a constantly looping program, and that's what Solidity is strong at. Solidity creates a Ethereum, I always want to say virtual machine, but it is an EVM, an Ethereum virtual machine, which is just a virtual machine. But you get a virtual machine, and you need that because you need memory, compute, and storage, and that doesn't exist on exactly in that way on Pact. Pact is not meant for this. Pact is meant for transactionality, not for general compute. And a server is a general compute because you need to loop. So that's the shorthand explanation. But the cool thing about Flux is they have all of these nice little additions. So they have something called a Lambda function. Okay, so you can spin up a teeny little looping server and put a function on it. Say 1 + 1 = 2. So 1 + x equals whatever the integer is. You get the idea. So you can input a 4 and then you get a 5 back. You can input a 6, you get a 7 back. You can make these little functions on the fly on Flux and then not have to spin up this big expensive server and stuff like that. You can just do this little teeny one. So it's that notion of all their services, they need a virtual machine to do this. And Solidity is perfectly set for that. So yes, it is scary that they go on Solidity because Solidity is insecure, but it's only insecure. So an imperative language is only insecure when you're a shit coder. That's the thing. And Dan Keller's team are not shit. But it doesn't mean that they're unsafe and can't make mistakes. Nothing is ever safe, even in Pact and Haskell. You still have errors that come up, right? Like we had a famous error in the code that is going around in our community. But the thing is that it's a lot less likely on Kadena mistakes will be made like that in terms of hacks and abuses. But on Solidity, much more so. But they're forced to because they're a server company. They have to do it that way. So the way that you could limit any damage Flux can do to our application, and not to say that they ever would, I never want to talk about them that way, is to make sure that your nodes and your instances are very simple and not complex with a lot of control, a lot of ifs and else's and loops and stuff. All I want to do with Flux is run what's called a Docker on it with the Pact smart contract on it. That's it. So we just keep it very, very simple, very, very loose, where Amazon is, super complex and they have a lot of different functions and things you can do. And when you allow people to have a lot of moving parts on these little virtual machines, it becomes more and more attack surface, more and more easy to crash those nodes. But I'm going to tell you something about Flux that is cool and why their system is different than Amazon. So I worked at Amazon. I was on their machine learning team in the book selling division. I used EC2 a lot. And EC2 is, you have to spin up your servers. It's on demand. And if your server goes down, you have to write a bunch of code to spin up a new one and stuff. But what Flux does is they have this thing called the load management system. I don't know what they call it. It's an acronym. It's kind of a weird one. But if you spin up, say, 50 Kuro nodes, right? We're trading and all the trading's happening. You got 50 Kuro nodes and one dies. All your computations can still go to the other 49 and they'll spin up a new one for you on the fly. So it's like a phoenix rising from the grave, and you get your 50 back. So they've really thought about the redundancy factor. I was very, very impressed by the interview that I had with them on Wednesday. I think I met them on Wednesday for kind of a real talk. And that was one of our first questions is look, you're building on Solidity, how are you going to do this for redundancy and reliability? These are the two things we need. You must be reliable with uptime and you must be redundant. So if you go down, that's not good. We can't have that. We can't have transactions dying. So what Dan told me was look, there was an app I think that they had, and they went down to 28% redundancy. They lost 75% of their servers, not even a second of downtime. That's what I like to hear.
That's probably the coolest thing I've heard, because I exited Flux when it was $1.50, just because the market was getting bearish and I couldn't. Flux is such a big animal, and I've started to do deep research into understanding Warren Buffett's investing strategy, where he says that you don't have to swing at every pitch, but understand what you're investing in. It'll add the most value to your investing career. Your career as an investor is really understanding the technology that you're investing in. I realized that I was holding on to Flux for 4 months. I've interviewed every person on their team. Huge fan of Dan, huge fan of their team. And I was in a live stream and I realized I couldn't tell you what the TPS of Flux was, right? How am I investing in something that I know such little about? I knew a lot about more than everybody else, but I didn't know enough to be comfortable you know, I just didn't feel like I had the time or resources to actually study the technology. It wasn't until hour 1100 on Kadena, literally 1100 hours of researching before it clicked. And it really wasn't until I started to see your team and understand like the type of talent that Kadena is going to attract that I really was like, you know, so I feel the same way with Flux. Again, I just learned something about Flux I did not know. I always was wondering in the back of my head, like, oh, somebody's going to replicate Flux on Kadena because of Pact. Now I know that they can't because of...
They can't because they need the EVM. Yeah, that's right.
That's
you have to have it.
Sweet. That's awesome. Good for Dan, man. I'm rooting for them big time, man. Like you said, their team is phenomenal. They don't get much of a better guy than Dan. Anything I need help with, he just reached out yesterday. You want to be our so we're looking for an event coordinator. I'm like, oh, dude, I'd love to throw Flux Festival. Actually, I reached out to him and it's like, hey, you should throw a Flux Festival. He's like, you want to be our event coordinator?
Look, I want to talk about KDABET so much, but one more note about Flux, and then you know, it's turning into like all Flux, which is great. I'm sure Dan will love it, but it's like I think right now they're at 30K servers, 30K nodes, which is amazing. That's a lot of nodes, and I think Dan was saying to me the other day, you know, forgive me, I hope he doesn't dungeon me or get Martin to throw me in the dungeon, but I think they're really scaling up in the next 6 months to get to about 70 or 80K nodes by signing on universities who have spare compute. So they have a lot of spare computers because they're buying computers every year at universities and schools. So he's really going after these basically compute environments that are being unused. And he's suggesting, you know, 70, 80K servers, because we're like, you know, we might need, because, you know, Ryan, a lot of computation for us is also on the market maker side. So market makers need to scale and build massive machine learning algorithms. So machine learning algorithm predicts something, but to make that prediction solid, you got to stack 1,000 of them up on computers. So we have a massive setup on like hard metal setup where we're running all of our probability calculations for sports betting all the time, 24/7. So that's another use case where we'll be using like maybe 10,000 nodes even at scale for all the market makers we're going to bring on, because we just know them all and we have relationships. So they're all going to run their machine learning algorithms with us, and we're going to give them that ability to hook in with the bot. And we need compute to do that. So there's another use case for the nodes. And just one note I wanted to make about the price of Flux. I totally get why you did that. I actually bought just before Coinbase, or I sold just before Coinbase. I remember that. I went from 1 to 3 and I got screwed. So that was my Flux experience. But when Flux makes money is when transactions flow through Flux, period. Same with Kadena. If you don't have applications that push transactionality through their system, and you get lots and lots of fees being paid and lots of people swapping on either KDS or KDEX when it comes out. You know, shout out to the KDEX boys when it comes out. But you know, you need a lot of capital flow and incoming capital from outside sources populating Kadena and coming in. So that's what we're trying to do by bringing in the bettors. So this is new money that doesn't exist in Kadena, and that's what Kadena desperately needs. That's why the price is not so hot right now, and the Flux price is not so hot, because it's kind of like Ghost Chain, right? A little bit. Now, I don't want to say that because it's not. There's a lot of great projects, CAD, Cars, Mock, all the guys are beautiful. But what we need is mass transactionality to come in. Yep. And when those nodes are on fire and under demand, and there's a price being put on the Flux nodes and Kadena, because it's in tandem, right? And the Zelcore wallet is flying, that's when Flux pops. And we're trying to build an application at scale like Betfair. We're trying to reimagine Betfair in the Web3 space, period. That's what KDABET does. When we get that type of volume that Betfair had in, it will be amazing. And then hopefully we are a use case for financial firms to see that, oh, hell yeah, you can build a limit order book right here on Kadena and Flux, and it can function under huge TPS pressure. That's when you get JPM, Goldman Sachs, CSE, Chicago Trade Exchange Board. I don't know if I said that right, but all these guys, man, that's what you really want. That's the end game of Kadena, and we're trying to build a use case for that.
Before you get put in the doghouse, Flux currently has 12,363 nodes up and running as of today. They broke the record. They broke the record at 10,000. I want to say it was. Flux is the absolute most decentralized cryptocurrency in the world with 12,000 nodes. No, we saved you. We saved you, man. So yeah, 12,000. But I think that's where they're trying to head, is they have the Titan nodes start taking off now, which will allow anybody with up to 100 Flux or something like that to actually begin staking Flux.
Yeah, and I was told that they're going to have an enterprise node for GPU as well. So, I got my bad boy over here with 3090 GPUs in it, and they might have applications for high compute. That's what I was told. I don't know when that's coming, but there is a name for it where you can actually say, I need scientific computing power. So in science, when you're solving molecular positioning problems or dynamic molecule movements, the amount of calculations that go with that is stupendous. Same with machine learning. And so these computers now that have big GPUs in it that are no longer mining Bitcoin because it's not profitable, you can now transfer it to Flux node and then have scientific computer guys like trying to make molecular drugs and stuff, or molecular calculations to make new drugs. They can come on and use your nodes now at a much higher price. So your nodes are much more profitable because you got to pay for GPU power, right? That's not cheap.
Absolutely. So I personally would use render services, render token, RENDR, whatever. They offer the render services where people like me, that for me to edit out your intro, for example, the other day, 4 hours, my computer was tied up just rendering that one video. Or I could have went on render and paid, 15 cents and boom, I have my video rendered out in a few minutes, So it's like Flux isn't just using just the nodes. They're going to be doing computations, like you said. They're going to have render services. They're going to have, Dan has some really big alpha launching this week. The new Zelcore upgrade, I think, is going to be one of the biggest utilities for them. And I think it's going to be huge for the Kadena ecosystem having that. Nobody really cares what wallet they're using, right? They care. I love Phantom. In my opinion, Phantom wallet is the best. I would interact with Solana's ecosystem just because the Phantom wallet is so simple. It's so easy to use. Zelcore's next upgrade, they have a few little things like, if your computer screen size is 200%, right? Everybody uses bigger screens now, so we're all zoomed in. Zelcore defaults opens up too big, and when it opens up, it's bigger than your screen, but you can't move it because you can't get to the top of it to pull it down. So for the longest time, I was like, F Zelcore, F this wallet, not really realizing. I was like, I had to zoom out my screen. I was like, what the heck? And just a few little things, and they're rolling out their new version of Zelcore, in this week or next week or something. It's supposed to be off the hook. And then
I've never had a problem with Zelcore. It's great. It's some of the visual can be done a little better, but it's kind of beautiful actually.
It is.
And I've never had a transaction fail on Zelcore in maybe 50,000 transactions. It's flawless.
That's beautiful, man. That's beautiful. And once it's not like people like us that it's the new people that never have dealt with crypto that you get into a wallet like Zelcore. It's, they have 6 wallets in one. I didn't, even being in the space for, a while, it took me a little bit to figure these things out. But I think everybody in the crypto space is really realizing you have to make things like the cypherpunk days and the days of the MetaMask, I think are pretty much long gone. Yeah. MetaMask didn't evolve. How the heck how do you be MetaMask and not have the baddest ass wallet in the space? How in the hell? They haven't really done anything to that thing, and it's just the same exact. You can't add custom tickers. You can't change anything in it. You can't even put a logo in it. It makes it not feel like a legacy business, which I think you need for global adoption. But hey, maybe MetaMask knew that Ethereum wasn't going to scale, and it wouldn't be. It's just a lost cause in the long run.
Yeah, one note on MetaMask, and then I wanted to talk a little bit about your question, and then Marmlade before we pop off, because that's a huge thing.
Am I saying it wrong? I thought it was Marmlade, like the drink.
Oh, I'm from a British family, so they're weird.
Okay. Oh, okay, cool. Yeah. All right, good. I just want to make sure I wasn't saying it wrong.
No, it's Marmalade, but my mom would shoot me.
Marmalade?
I said,
I like it.
Yeah,
I dig it, man.
So, just one note on I think I still have 4K Polygon, $4,000 of Polygon in MetaMask because I never figured out how to send it to Ethereum chain. I just couldn't figure it out because the UI was bad. Fuck it, sorry for my language, but I said, I'll just leave it there. Maybe one day I'll get it back. So I still have 4K, $4,000 worth of Polygon 3 years later. It's maybe it's 8K now, which would be great. Or actually, no, it crashed, so we'll see. But yeah, maybe go on with your question you were saying there. Then we could talk a little about Marmalade, maybe.
Wait, when did you have that Polygon there? What year did you buy that?
I bought it when it was $1.18, and then it went to $3.
Oh, okay. I thought you were implying you bought it in 2017. I was like, dude, you got way more than 4,000. Polygon was 2 cents.
I got screwed. It was $1.18, and then it went up to 3 something, and then I was pretty happy about that. And then I just never checked it again because I couldn't figure out how to use the wallet. just gave up 4K because whatever.
MetaMask is funky, man. And it's so funky that it's so easy. I would show you in 2 seconds and you'd be like, wait, that's how that thing works? I know I did. I've had MetaMask for 5 years and I didn't use it till like a year ago. And when I found out how somewhat simple it was, I was like, wow, I can't believe I've
just want to throw my computer in the fireplace when I use it. It's like,
yes,
can't stand it.
I hope that Kadena, and it seems like that's what they're really focusing on, is that to drive the demand of global adoption, you have to have things so simple. And they also touched in that Medium article about how they understand that when you're building greatness, like when you're building a technology that's so disruptive that it has the opportunity or potential to change every aspect of life, of course there's going to be that developer learning curve. Of course they're not going to have things in everything perfected right now, and that's why we're getting Kadena for $2. Come 6 months, a year from now, when I was able to teach my 8-year-old how to write a packed smart contract. You couldn't do that in Solidity, I don't think, right? You understand Solidity. Could I teach my kid in 8 minutes or 10 minutes how to write a smart contract?
No, because he struggled with the concept of classes and stuff, because that's not easy, because you have to tell everything where to go in imperative language. This is how you have to build everything from the machine level up. The reason why Pact is so simple, it's a declarative language and it's interpretable, it's human readable. That's why Pact is beautiful. So even an 8-year-old understands how to add two things together and build that system and bring that function to the data and get a result. And it's because everything is readable and simple and put in nice parentheses. So the beautiful choice I think Martino and Popejoy made, forgive me for calling them by their last names, but it's just easier. They decided not to go with Haskell and build in Lisp in terms of their interpretive language. So that's their interpreter language. So that's what you're actually coding on. And Lisp was invented in the 50s for this very reason, is people didn't want to code machine code. So like C++, you're deep in the weeds dealing with memory and pointers and control flow, and it's just garbage when you can just write this simple mathematical language. It's just like plus Ryan Matta string, done. Like, even a kid can understand that. And maybe, we should hire your son here, man. He's doing awesome. We should hire him before he gets too good and too expensive. And
yeah, before you can't afford him, for sure. I think I've asked several people this, but if you were an experienced, like the best experienced Solidity developer, and I was the best experienced Pact developer, and we both wanted to build applications, what would be the percentage that you would say that somebody on Solidity, like if I wanted to rebuild Aave on top of Kadena, or if I wanted to build like Aave from scratch on top of Polygon, what would be the difference in percentage wise if you would have to take a guess?
Okay, so you have to be aware that it has to fit on Kadena. So Kadena doesn't fit for EVM type programs like Flux, for instance. So if it's generally a program that you can launch on both, the productivity is an order of magnitude higher easily. You'll be 10 times faster on Pact. It's just the reason why people are a little slow is because they don't understand declarative language. But once they do, once it clicks and the light bulb goes off, like for Adrian at DocuShield, great guy, by the way, the productivity is ultra fast and the code is much, much less dense. Way more code in Solidity. You have to try a lot harder. So the productivity is 10 times faster, easily, for this same level of programmer. And that's just because everything's human readable. Now imagine when you compile and you put your smart contract on the node and you get errors. You don't know anything on Solidity because it's compiled into what's called bytecode, zeros and ones. It's just zeros and ones, Ryan. Like, unless you're commander data, you can't read that. But on Pact, when you have an error, you can see exactly where that error happened because it's an imperative language. It's human readable language. Again, genius choice by Stuart Popejoy for doing this. It is an amazing choice because I think they intended Pact for productivity. They understood functional programming language. Declarative language is meant for productivity and quick code because you're not coding these complex EVM style where you need an EVM complex control logic. It's just like, we're making transactions. We know what we are. We're designed for what we know we want to be, and let's make that productive as possible. So they chose like the best possible language, which is Lisp, for their very simple setup, like the building of the modules, the table, the keys, the functions, which you went through in your tutorials. Yeah, vice versa, man. I just really enjoyed our time together and look forward to doing some more conversations in business perhaps together.
Dude, love to, man. Anytime. So have a good one, Steven, and I'll get you a copy of this video as soon as my editor gets it back. So thanks, man.
Super. Thank you.
I appreciate it, buddy. Later.